Hello everyone, this is Debabrata once again, and today I am planning to show you one simple chapter like character. And if you are already gone through all the previous chapters and if you are following my playlist already, so I hope this will not be an issue. It is not that important as well. It will be an easiest one. Okay, trust me. So if I jump into that topic quickly, uh, so today we will cover the character in C, and as a prerequisite, nothing much, just the basic idea how you can write the C programs. That will be enough. So just the normal things and nothing special. And obviously you have to practice all the things I am showing you, because those concepts later will be used in the chapter of string. So character, we can say it is just an entrance of a string. It is nothing complicated, but yeah, later this concept will be used in string. But as a chapter, it is a simple one. So character is just a new data type. We have already explored the data type like int, float here. So character will be just the addition. If I go to the uh, a compiler, so you can use any compiler in your case. So it might be online compiler, it might be anything, Tarbusi or anything. If you face any challenges, just let me know. First, try to print the high. If high is getting printed, then everything else is fine. So I will introduce one first. Let me show you how one integer has been assigned. It is very simple. So I can take something like int a equals to 10, and after that printf percentage d and a. By doing this, I can print one integer value. So character is just, as the name suggests, it is just a data type. It is nothing more or nothing less. It is just a data type. And whatever characters you can see, if you are using the keyboard, in your keyboard, whatever you can see in front of you, whatever the keys you can see in front of you, all those keys are a part of the character. So let me show you. So here it is very simply printing the integer variable. So now this is the time to explore the character. So I will make it character, and character variables always, character values actually always, we need to keep them inside the code, inside the single code. Just remember that. So let me put some alphabets first. Suppose let me put Z. And now if I print at the printing time, I need to make it as percentage C. That is something important. So now if I run, so it should print Z only because it is a character. If I put multiple characters like Z, Q, W, something like that, and if I try to run this, so it will print only one character. And by default, it is taking the last one. But again, character means you have to give only one character, not multiple. If you give multiple, it will not going to print all of them. So it can be an alphabet. What else you can see in your keyboard? A number, suppose 1. You can see it in your keyboard. So 1 as a character. Again, what can I use? You can use some question mark. You can use some space even. You can print anything. So let me put question mark here. So you can see question mark is being printed in the output screen. What else I can show you? Everything is character that you can see in your keyboard. I can use, I can write percentage. So everything. I hope the idea is clear. Just you need to write as integer works on percentage D. Similarly, a character works on percentage C. Okay. So now let me take an input. So if I take an input, it will be something like I can print like printf. I can ping something like enter a character. What is happening here with McAfee? Okay. Enter a character, I can say, like the same way I ping like enter a number, I can ping like now enter a character. So I will just do the scanf on percentage C. Just remember, I'm not writing percentage D, it is percentage C. And everything else is pretty much similar, you can see. So now if I run, so let me take an input of like at the rate. Suppose if I enter, it is printing at the rate again. So I can write here something like you have entered and a space and percentage C. So now let me run it once again. if I enter something called, let me put a bracket, second bracket, anything you can choose from your keyboard. If I enter that, it is saying you have entered a bracket. So yeah, it is perfect. So now we have seen how a character can be taken as a new data type. So now, if it is a question, the main challenge of this chapter, I will not say the challenge, the main thing that we need to learn from this chapter is, what do you mean by ASCII code? ASCII code is something important. Otherwise, character is just like integer, just like float. It is nothing special, nothing new. You do not need to worry about that, because on the first day when you started with integer and float, you might feel the same, like, okay, what is integer, what is float now? But after using them for all in all these chapters, now you are very comfortable with integer and float, and characters will be in characters it will be the same case. After using one or two class, it will be also clear, it will be also become easier. But we need to learn something new, like ASCII code. What is ASCII code? So suppose you have entered some character, and now if you want to print the ASCII code of that character, we are able to print the character itself. Okay, probably the spelling is wrong. Yeah, let me correct it. Yeah. So now if I want to print the character, so there is two way. You can write percentage D in place of percentage C. Okay. So let me run. Let me run. So suppose if I enter capital A, suppose. So it is saying you have entered 65, or I can change the statement like ASCII code of percentage C is percentage D. What does that mean? I will write A twice here. So first time percentage C means the character version will be printed, and after that the ASCII version will be printed. I think the print will be smooth, means everyone can understand what I'm trying to say. So now if I enter small a, it will print like ASCII code of small a is 97. So these two particular values are very important. These two particular values. So ASCII code, we have 128 ASCII characters defined in our keyboard that we can see. ASCII means American Standard Code for Information Interchange. Okay, let me write that. American Standard, but no one is going to ask you during the interview about that. The American Standard Code for Information Interchange. So that is, in short, is called ASCII. So you do not need to remember any ASCII code. Why? Because even if you do not have any internet connection, still you can just take an input and you can print, you can write this program, and this program will return the corresponding ASCII code. So by which I came to know, like capital A is having an ASCII code like 65. Small a is having ASCII code like 97. So similarly, it will be in sequence. So capital B will be 66, capital C will be 67, capital D will be 68. Let me show you. So if I give capital D, just take a look. Uh, if I enter capital D, it will be 68. The same thing I have written. So now in that fashion, what will be the ASCII code of capital J, capital Z? Just I will request you to put the screen on hold, put my class on hold, and just calculate and then resume it back. So capital Z, I have heard, most of the answer that I have heard from the student is 65 plus 26. That will become 65 plus 26, because Z is a 26 character and the first character is 65. A is 65, so it becomes 91. But that is basically a wrong answer, because D is now, if I follow this approach, it is a something called mathematical term, inclusive, exclusive things are involved. But if you are not good in mathematics, in a common sense, you can see D is the fourth character. But we are not doing something like 65 plus 4. So the answer should become 69 in case of D. But in case of D, we are doing 65 plus 3, one value less, because A is included here in the calculation. So if you do not able to understand that, just ignore that. Just simply think D is a fourth character. So I have done something like A plus 3 to get the fourth character. So to get the 26th character, I will also do the same. I will do 65 plus 25. It is 90. Even if you write all the ASCII code one by one, you can see the magic. Z will become 90 in a simple way. Do not need to remember all those mathematical terms. Z will simply calculate it as 90. If you go forward, just complete the series E, F, G, everything you write. If you go until Z, it will become 90. Let me check if it is behaving same here as well or not. If I give capital Z, so it will be 90. Yeah, it is not 91. But most of the answers I got in the class is 91. So in the same logic, small z will be 122, 97 plus 25. So if I enter that, small z, yeah, small z, it will be 122. That's all. So it is the ASCII code, and the rest of the things do not need to remember. Sometimes I remembered, but not correctly. Zero probably starting from 48, probably. But again, if you forget something, just write this program. This program is very easy. Just run the program and enter zero. It will show the ASCII code. Yeah, zero is starting from 48. And believe me, I do not remember anything else. I just remember three numbers, three characters. Capital A starts from 65. Small a starts from 97, and sometimes I forgot, sometimes I can remember, like zero, the number that starts from 48. So everything in your keyboard is just a character. It is not integer. The number here, zero, I have put, that is not a integer. So what is the difference between integer and character? If you add integer 1 and integer 1, it will become 2. We have done lots of time this type of calculation. But if you add character 1 plus character 1, it will become 11, because these are just the characters. So that is the difference between integer and character. Character will be treated as a text value. It is not like a number. It is like a text value. Okay. So if I go to the slide now, the next question is saying enter the ASCII code and print the character. Okay. I forgot to mention one thing. You can, some people also write this kind of thing. I have mentioned, like, I will show you two approaches. So sometimes people mention this approach as well, int a, but it is not required, because if you simply write percentage d, the ASCII version or the number version or the integer version of that character will be printed. So you just need to remember one thing: ASCII and the characters are equivalent. It is nothing like we are converting something. So important point to remember in this class. Let me put some star. ASCII and the character, they are same thing. It is not like we are converting something or we are doing something. Those are same thing. If you want to see it in a percentage D format, you will see the ASCII. If you want to see it in a percentage C format, you will see the exact character. So they are same. They are exactly same. Okay. So now the reverse one, enter the ASCII code and print the character. So that comfortability, that flexibility you need to generate. So now I will write integer, and I will write in enter the ASCII code. So someone suppose entered something using percentage D, obviously it is integer. So now whenever I will write the character is, sorry. So I will write character is, I will simply write percentage C, and I will print A here. Some people converts their thing, but again, that is not needed. So if I enter some ASCII like 66, so it will give me capital B. You can see what some people do. Some people just write something like char, suppose B equals to, they try to convert the integer into character, and after that they print B. That is okay, but I will say it is not needed. If you keep that in your blood, like, okay, if I enter 67, it is character is C. So if you keep this line in a blood, like ASCII and the character are same, it doesn't require any changes. If you can write this, you will get a satisfaction like, okay, the integer value, I'm changing that to character. But if you want to become the pro, if you want to really understand the heart of this chapter, we do not have any complicated logic. Even you can see, we are just introducing a new data type with some different example. That's all we'll be doing today. But here, if you do not convert anything, if you just print the percentage C version of an integer, then also it will print the character. Okay, this value is integer. If I write A is an integer. But percentage C format of that integer will always represent the character. So the character and ASCII goes hand by hand. Okay, so you do not need to put any logic there. So next one, print the full ASCII table, and it is quite important. If you want to see, obviously every one of us want to see what are the ASCII codes table, what are the ASCII codes we have. So generally, okay, now we are not going to take an input from the user. What I'm going to do, I'm just writing a for loop, I equals to 0 to I less than equals to 127. So we have 128 characters in our keyboard. And currently, I'm just going to print that one. So I will just write percentage D and a small hyphen, and after that percentage C. So first it will be filled up by I, next one is also filled up by I. So just to print the integer version, the ASCII version, and the character version. I want to print both. Just I'm trying to play with that. Okay. So int I. Character, we do not have any logic to solve in this chapter, just to introduce character like all other data types. So now everything is getting printed. You can see 0, 1, those are being the different shapes are being printed. Probably these are, I cannot see these characters in my keyboard, but for someone it might be there. But something is, if you have any music button, that is 14. So there are many, but I can see something good from this 33 keyboard. Okay, so let me check. Yeah, so you can see here after 10, there is one enter has been pressed. So probably enter is in 10 character. Okay, so one extra line you can see. 13, something is deleted probably. So I guess either space or something has been deleted. So you can check even just by inputting something. In 32, I can see nothing. So delete, the backspace, spaces, everything is included here. You have to just explore. But from here, I can see it is available in my screen, in my keyboard. 33, 34, here it is. So from 48, the number should be started, as we have just checked few minutes back. Yeah. So all the numbers you just need to calculate manually. That's all. From 65, it should be the alphabets. Yeah, I can see all the alphabets are here till 90. Even you can, I have told you Z will come at 90. You can also do it by yourself and check. Generally, Z is coming to 90. But most of the people are confused with the calculation. They say like Z is 91, but that is not. From 97, small alphabets should come. You can see. So till 122 as we have calculated. And after that, some brackets, something like that, and that's one. So that is our ASCII table. You can see, you can anytime, you do not need to remember any ASCII code. You do not need to remember, do not need to save any Google page to see the ASCII code. Anytime we can print it by ourselves itself. Okay. You do not need to take any help from internet. So that's the thing with the topic one, very simple topic. And if I go to the topic two, ASCII code and a character is equivalent. That I was trying to I was trying to present that thing. I was trying to put that in your mind, like ASCII code and the character is equivalent. So we will check out some exercise by which we will confirm like, yeah, both are same. So enter a character and check if it is uppercase alphabet or lowercase alphabet. So as an example, if I give capital B, it will say uppercase. If I give Q, small q, it will show lowercase. If I put 7, it will show digit. And if I put anything else, it will say like neither alphabet nor digit. So let me take an input of characters. So let me delete all this. It is nothing major, I can see. So just character, carry. And after that, I can write printf, enter a character. And after that, I will take the input inside using percentage %C and using percentage %C inside the variable A. So now, what people do generally, people just directly do something like int, they write int B, and quickly they convert the character variable into the integer variable by just typecasting. We have learned what is typecasting in our chapter 1. Just we need to introduce that. So they are converting their characters into the integer value, and after that it becomes simple. They can use a if thing. They use something like if b is greater than equals to 65 and sorry and b is less than equals to 90, then I will going to printf uppercase. If else if, obviously we know how to write the else if, and now our number is in integer, so probably you are happy like we are dealing with the integer number, and it is our it is very easier for us to deal with the if thing because we have learned if in our chapter 2. So you might feel comfortable now that a character has been converted to the integer, and we can simply lightheartedly we can write all this program without thinking anything else. So the next one is the b is greater than 48, and I forgot actually it is probably 57 029 probably. I forgot, but again I will not waste my time just by checking. So it might be 57, but yeah, I forgot that thing. It is 57 or 58, or I have to, I'm not that good in mathematics, so I'm not taking the risk to calculate anything. So after that else, if nothing is matched, then I can print what I need to print, neither alphabet nor digit. So I will print neither alphabet nor digit. So that's all. So let me run this program, and I will solve this program in 3 different ways. I will show you what I'm trying to mean. So if I run this program and if I enter something, say if I enter capital R, so it will show uppercase. If I enter small q, so it will show lowercase, obviously. If I enter a number like 5, so it will say like it is a digit. Okay, it has, okay, let me run it once again. If I enter something digit, it will say digit. And if I enter anything else, any other characters like star, like anything, so it will say neither alphabet nor digit. So I hope the idea is clear. So this is approach 1 I have taken. So approach 2, what I will do, I do not need to convert it into the character, into the number. I can compare a character directly as well. So I will just write A everywhere. I'm not going to write B. I'm not going to convert it to any number. So if I write A, that should also work. So I'm not converting them directly. Whatever you feel free, I am trying to show you some general approaches. So if I give capital W, it will be again uppercase. So I'm not, I have also, we have also seen some examples in the previous slide, kind of that, where we do not need to convert anything. If you write anything, it will take it automatically. If I write small k, it is lowercase. So everything will be taken or converted automatically. So you do not need to put it inside any integer variable. Character variable is enough to compare. So that is approach 2. If you want to become more flexible with the character, here you can directly use capital A as well. If you forget the ASCII code even, you do not need to write the ASCII code because ASCII code and the characters both are equivalent. So here I can write this thing. And I forgot it was ending at 57 or not. So it will be safe for me as well if I write 9 directly without doing any calculation. I was really scared if the 57 was the correct ASCII code or not. But if I use this approach, it will be pretty much easy for me. I do not need to calculate any ASCII code, or I do not need to remember even any ASCII code. So if I write something like enter a character, like let it be like capital E, it is uppercase. So everything should work. If I do something small e, it will be lowercase, you can see. If I run any number like 3 or something, it is a digit. And if I give any other output, any other inputs like plus or something, it will neither alphabet nor digit. So this is the answer of the program. And you can see one very small topic, one very sensitive topic, why character use quotes. Here, if I do not use quote, people will think A is a variable. So on the left side A, if I only pick up this one, if I only pick this line, so here how we can understand which one is variable, which one is value. So here it is the variable and here it is the value because it is under quote. We didn't use any quotes in case of integer because integer variable can easily understandable. If anyone write this, anyone can easily understand A is a variable, 5 is the value. But in case of character, if I remove this, people will be confused which one is the variable, which one is the value. So if you want to compare or if you want to deal with the character values, that's why they have made a rule that you have to give a quote. It is nothing like it is written in syllabus, it is written in book. That's why we are using quotes. If you have any other idea, you can present that to C language forum. They will think about that. But the main answer will be they are using quote just to differentiate between a variable and a value. We didn't have this kind of problem in case of integer, in case of float, because those are the numbers. But here it is a character, so there might be a chance that it will be mixed up with the variable name. And that's why they are referring that you have to use a single. You have to understand that. Otherwise, the chapter is not that tough. It is very easy. So enter an uppercase character and convert it into lowercase. So it will be easier as well. So someone if enters a character input, and first I will check if it is in uppercase or not. If not, I will directly print it like not in uppercase. I will directly print not in uppercase. And if it is in uppercase, what I will do, I will simply do something like, okay, let me introduce a bracket. There will be multiple lines now. So I can write a character suppose B, and I will do simply what people does, people generally convert it to integer, then do the minus. Character and ASCII codes are familiar. They are equivalent, the same thing. So I can simply write A minus or lowercase a plus 32. Because what I can remember, capital A is 65 and small a is 97. Capital A is 65, small a is 97. So if I want to convert that into small case, I have to do this plus 32 because all other characters after that are maintaining that same difference. Because capital B, if I choose, it is 66, capital small b will be 98. So they will maintain the gap like 32. So if I do the addition, it will become the uppercase. It will become the lowercase. So now I can print something percentage B with what I'm writing, percentage C for character, and I'm going to print B, the variable B. If I run this program now, and suppose if I enter something, say capital B, so it or capital D, it should be converted into small d. You can see you do not need to convert it into integer. Then just for doing a sum, you do not need to convert it into integer, then sum, and then convert again into character. Do not need to follow those long steps. Even if you want, you do not need to introduce b equals to a plus 32 even. You can simply write a plus 32 here. It will work. If I run again, suppose I'm giving capital E, so it will convert it into small e. And if I give anything other than these values, suppose if I am giving 5, so it will say not an uppercase. So if it is an uppercase, we will just doing simply a plus 32. And that knowledge you have to put in your blood, that the ASCII code and the character is equivalent. Okay. So if I go to the question number 3, enter an alphabet and print its previous alphabet. So obviously it will be the same thing. So I do not need to put any if or anything. I will just write previous alphabet is, obviously if anyone doesn't enter anything like which ASCII code is 0, except 0, we can input anything. So I can just write previous alphabet is percentage C, and I will not do any plus minus explicitly. I will simply write a minus 1, and that will work, the previous alphabet. But remember, if anyone enter the first character, then it will give some problem. But I do not have anything The first character in my keyboard I cannot see. So I can give anything, like I can put small e, it will return small d. So same thing, the previous characters. If I enter 9 character, it will return alphabet 8. So same thing again and again. Okay, if I give anything like percentage, the previous character is dollar. So it will be printed. Okay, so you can easily print the previous alphabet just by a small line a minus 1. But people, many times I have seen, most of the time I will say, they are confused with this approach. They think character is like an alien. We cannot treat it like a normal variable. So it is not like integer. So, but do not treat it in that way. Be flexible with character, and character is very simple one. So we have already checked that output. So I guess that's all for the day. So if you have any problem with the exercise or anything, you can tell me. And we have a nice exercise defined in our Facebook group. Probably you know the address. If you do not know, you can just go through the links that has been provided in this page, in this slide. You can just go through that. Even if you are confused with something, write it in the comment section. I will try to answer that. So you have to just go to that group, and after that you will get some option like media. So if you go to the media, and if you go to the album quickly, you will get an album called Coding Exercise Basic, the first one probably. Yeah, if you click on that, if you open that, and you will get chapter 7.1, and that is created with characters. So yeah, here it is. It is a very small chapter, so you can just take a note of that. You can see. Okay, and it is a very easy chapter, only 12 programs, and you do not need to run your brain, because nothing logical is there. So just need to be comfortable with the character data types. That's all. That is the purpose. So that's all for the day. See you once again with the further chapters of characters. Bye for the day. All the best.